Hello TSAT viewers. Last class lo మనం sampling techniques unit start చేసాం. We'll continue that topic. See here, sampling errors and non-sampling errors. So what are these sampling and non-sampling errors? See here, there will be many errors occurring while collecting the data, processing the data and analyzing the data. So all these errors are classified into two types, that is sampling errors and the non-sampling errors. So the sampling errors చూద్దాం first. Sampling errors లో first faulty selection of the sampling technique. So last class మనం sampling techniques చూసాం, simple random sampling and as well as stratified sampling and also systematic sampling. So these are the three sampling techniques we have discussed. Apart from these, there are many sampling techniques. So whenever the sampling apart from these three sampling techniques, we have many sampling techniques. So whenever you are sampling from the population, you have to be particular about which sampling technique you have to apply on that population. So if you apply that, if you select the faulty sampling techniques for the population, then then this kind of errors will occur. The faulty selection of the sample. You have to select the appropriate sampling techniques for the populations. Next, the substitution. So in the simple random sampling, you'll see, so there is a population till x1, x2, so on up to xn candidates are there. So I have included some A, B, C, D, E, F candidates into my sample. So from this population. సో ఇప్పుడు నేను ఏం చేస్తాను, ఒక ర్యాండమ్ పర్సన్ దీంట్లో శాంపుల్లో తీసుకుంటాను అండ్ ఐ విల్ నోట్ డౌన్ హిస్ డీటెయిల్స్ అండ్ వాట్ ఆర్ ద ఇన్ఫర్మేషన్ ఐ వాంట్. ఐ విల్ జస్ట్ remove that person from the population and I will select some other person in random and again I will get details for the particular person and I will take away from population. So whenever, let us consider some person A, I have selected this person A into my sample, I have to get all the details of all the details I want from that person A. Now if this person refuses to give me the answers, so what I will do, or if he may just refuse to give the answers, or he may be not available on that time, or any other issue. So whenever this person A, we are unable to get the data from that person A, what we do is just substitute some other person in place of A. Let us consider A dash. So this kind of when you take A dash here, so basically you have to consider the A information, but instead of A you are considering the A dash information. So this kind of substitutions will occur during the sampling. That kind of errors are nothing but the substitutional errors. Now, so whenever you found after taking the sample, from the sample you find statistics. So from the statistics you have to estimate the parameters. So in this process if any errors occur, then that is called the estimating statistics to parameter errors. Now we'll come to non-sampling errors. So in this non-sampling, what is the difference between sampling errors and non-sampling errors? The first thing we have to discuss that. What is the difference between sampling and non-sampling errors? The sampling errors are nothing but the errors which are occurring during sampling and while estimating our calculated statistics to our parameters. Okay. These non-sampling errors are the errors which are occurred after sampling and after estimating the parameters. Apart from these errors, what are the errors that are occurring in the collection, classification and presentation of data? That is called the non-sampling errors. Now in the non-sampling errors, the first is faulty planning. So whenever you want to do a sampling, whenever you want to do a sampling, the first thing you have to do is you have to be very perfect about the sampling, about in which geographical area you have to do the sampling, or else which sampling technique you have to use. So and also after finding the samples, how we are estimating that sample to the statistics to the parameters, and after that how we are generating it. So this all comes under the sampling planning. So we have to plan everything before we go for sampling. So if there are any errors occurring in the planning, then that kind of errors we can call it as faulty sampling. Next one, response errors. Response errors ఎలా ఉంటుంది చూడండి. So there is a population, an enumerator went to the concerned person, let us consider the P, the concerned person. Now, if this when enumerator went to the person and asked that person about the details, he refuses to give the answers, or he will just give the wrong information to the enumerator. He just give the wrong information to the enumerator. It may be any reasons. Either the person, it may be not feeling comfortable or not willing to give the correct response. That may be any reason. So whenever he gives the wrong response, then that kind of errors is called response errors. So, and again, non-response errors. Non-response errors are, so this person is totally unwilling to give the response to the enumerator. That is one case. Or this person is not at all available to give the information. So those kind of errors will come under non-response errors. Now, so whenever we have in the planning, we have already fixed in which geographical area you have to get the you have to do the survey and all. So when we have enumerators sent to the geographical location, these enumerators may not cover the whole geographical area. So in that situation, the data which we got and the calculations which we do, we are applying the data for whole geographical area, but these enumerators didn't collected the whole data of the geographical location. So this kind of errors will occur. So that whatever the results what are the results we are getting of the calculations, they are not accurate, they are not correct. So these kind of errors are called errors in coveraging. Next, compiling errors. These compiling errors are nothing but when you get the data, you have to compile the data and calculate, analysis. So whenever there are errors occurring in that process, then we call that as compiling errors. Next, publication errors. So after calculating, analyzing and everything you have done, so last you got results. So when you are publishing these results, there may be typing errors, there may be some misunderstanding between okay, cut that. So there may be any typing errors. So this kind of errors are called publication errors. Statistical inference. We have taken a population, and from that population we have considered a sample. ఈ sample నుంచి మనం different statistics కనుక్కుంటాం. We will find different statistics. It may be a mean, it may be a standard deviation, it may be a range or anything. So we will find a statistic here. Now what is our immediate step is we will estimate this to the population. So this is the process of sampling technique and statistical inference. This is called sampling techniques, and after finding the statistics while estimating to the population, that is nothing but the statistical inference. Now we have the population, the data, the population of data. Now this data will follow some probability distribution. This follow some probability distribution. Let us consider it is following binomial. It is considering binomial distribution. Now this binomial distribution, we have parameters n comma p. Now we'll write a possible set of all the parameters which this probability distribution can take. N1 and we have the parameters n comma p. Now this probability distribution can take the different values of parameters. So the set of all possible parameters, so this set is called parameter space. So this space or this set will consist of all the possible parameter values that a binomial distribution can take. Okay. So that is nothing but the parameter space. Now, so in the parameters, let us consider we are estimating the mean of the distribution. That is a parameter we are estimating. Now we have drawn a sample. Now we have to estimate this mean. Our goal is to estimate the mean of the population. We have for that we have drawn a sample. So we will write a function considering all the values of the sample. Let us consider that as Tn. We'll form a function which will take all the possible values in the sample. Let us consider that is Tn of x, where x can take values 0, 1, 2, so on up to n. Xi, let us consider xi. The sample is x1, x0, x1, x2, so on up to xn. That is a function on the whole sample. Now, using this function, we estimate our mean. Then this function is called estimator. This function is called estimator. Now, each and every value that is the estimator is considering, that is called an estimate. Now, let us consider an example. Idantha meeku chala boring undi. Let us consider an example which we can clearly understand. Let us consider a parameter mean theta. ఇప్పుడు నాకు శాంపుల్ ఉంది. శాంపుల్ వాల్యూస్ మొత్తం x0, x1 అప్ టు సో ఆన్ అప్ టు xn1 కు ఉన్నాయి. సో ఐ హావ్ టు రైట్ ఏ ఫంక్షన్ tn ఆఫ్ x. సో మీన్కి మనం ఫంక్షన్ ఏం రాస్తాం? 1/n into summation of xi where I takes values 1 to n. So this is a estimator. Estimator for what? Estimator for the population parameter theta. So now it will be very clear. A function, it may be anything. Now I'm finding standard deviation. Now my Tn of x will become 1/n into summation xi minus x bar whole square under root. This is a estimator. For what? For estimating the standard deviation of the population. So the function whatever you are writing to estimate a population parameter, that is nothing but an estimator. Okay. Now we'll see what are the properties of this estimator. What can be the, how we can say an estimator is a good estimator. We'll see the few properties. Characteristics. Now first, unbiasedness. See here. I have the parameter which is theta. Now I have the sample and I am finding the sample statistics. So in order to find the parameter theta, I am writing functions Tn of x. Now whenever I take expectation of Tn of x, if it is equal to theta, then I can say that this estimator Tn of x is a unbiased estimator. Now let us consider an example. Population parameter, let us consider it is a mu. అంటే మీన్ కనుక్కుంటున్నాను నేను, పాపులేషన్కి మీన్ కనుక్కుంటున్నాను, విచ్ ఈజ్ ఈక్వల్ టు మ్యూ. ఐ హావ్ టేకెన్ ఎ శాంపుల్ అండ్ ఐఎమ్ ఫైండింగ్ ద స్టాటిస్టిక్ x bar which is equal to 1/n into summation xi where I takes from values 1 to n. Now expectation of this 1/n into summation xi which is equal to mu. Now this is an unbiased estimator for estimating the population parameter mu. That is small derivation untundi, we don't need the derivation, just remember this statement. Expectation of small x bar which is equal to mu. So sample mean is sample mean kada. Sample mean is an unbiased estimator for the population mean. Now let us consider I am finding the variance of the sample, that is sigma square. Now what is the function I can write Tn of x? Now 1/n into summation xi minus x bar whole square, ade kada variance formula. So that is the function I will take. Now is Tn of x is equal to sigma square? Not. So don't worry about the derivations, just remember this statement. Expectation of this, expectation of the population, expectation of the sample variance is not an unbiased estimator for the population variance. Now let us consider small s square which is 1/n into summation xi minus x bar whole square. Expectation of small s square is not equal to sigma square, but there is one more function we will take. So Tn of ఇది unbiased estimator అన్నప్పుడు I have to consider one more function just to make it biased, unbiased estimator. So I'll consider s square is equal to 1 by n minus 1 into summation xi minus x bar whole square. Remember, small s ki ikkada n untundi, capital S ki ikkada n minus 1 untundi, that anta difference. Now this capital S square is an unbiased estimator for the population variance. Remember, the expectation of small s square is not an unbiased estimator for the population variance, whereas expectation of this capital S square is a unbiased estimator for the population variance. So small s ki capital S ki only difference is ikkada divide by n chestunnam, ikkada divide by n minus 1 chestunnam. So that's the thing you have to remember here. So the relation between small s and capital S, just write here. n into small s square ఏమవుతుంది ఇక్కడ, summation xi minus x bar whole square అవుతుంది. అలాగే n minus 1 into capital S square ఏమవుతుంది, summation xi minus x bar whole square అవుతుంది. సో ఇప్పుడు ఈ రెండు ఈక్వల్ కదా, summation xi minus x bar whole square. Now I can frame the relation small n into small s square is equal to n minus 1 into capital S square. That's the relation you have to remember. And you can write in this other form of small s square by n minus 1 is equal to s square by n. This is also you can write. So the relations you have to remember, relation between small s and capital S, and expectation of capital S square is equal to sigma square, but not expectation of small s square is not equal to sigma square. So the statement is very, very important. So the thing what we have discussed here, it is sample mean is an unbiased estimator of the population mean, whereas sample standard deviation is not an unbiased estimator of the population variance, whereas expectation of capital S square is a unbiased estimator of the population variance. Now, consistency. Now, whenever my n tends to infinity, I am saying my function is Tn of x, where Tn of xi, where xi value is taken 0, 1, so on up to n. Now if this n tends to infinity, when that n tends to infinity, my Tn will have to tend to my parameter theta in the probability. Now how we write this? Probability of Tn minus theta is greater than epsilon, which must be equal to 1. అసలు దాని మీనింగ్ ఏంటి? వాట్ ఈస్ ద మీనింగ్ ఆఫ్ దిస్? నౌ ఎప్పుడైనా మనకి శాంపుల్ వాల్యూస్ x0, x1, x2 సో ఆన్ టు xn వాల్యూస్ తీసుకున్నప్పుడు వెన్ n టెన్స్ టు ఇన్ఫినిటీ, దాని మీనింగ్ ఏంటి? మై శాంపుల్ ఈజ్ టెండింగ్ టు పాపులేషన్ కదా. n ఇన్ఫినిటీ వరకు తీసుకోవచ్చు, అంటే ఎంత ఎక్కువ పాజిబుల్ వాల్యూస్ అయితే అన్ని ఎక్కువ పాజిబుల్ వాల్యూస్ తీసుకోవచ్చు. దెన్ ఇన్ దట్ కేస్ మై శాంపుల్ విల్ టర్న్ టు పాపులేషన్. నో అదే ఇక్కడ చెప్తున్నారు. ఇప్పుడు Tn ఆఫ్ x అంటే ఏమొస్తుంది, ఇక్కడ శాంపుల్ స్టాటిస్టిక్స్ వస్తుంది, శాంపుల్ స్టాటిస్టిక్స్ వస్తుంది. సో నా ఇక్కడ n వాల్యూస్ ఇన్ఫినిటీ వరకు తీసుకెళ్తే అప్పుడు ఏమవుతుంది, ఇప్పుడు Tn ఆఫ్ x మనకి పారామీటరే కదా అయ్యేది. సో ఇట్ ఈస్ కన్సిడరింగ్ ఆల్ ద వాల్యూస్ ఇన్ ద పాపులేషన్, దెన్ Tn ఆఫ్ x will directly become parameter rather than statistic. Now that's what here it is saying. Tn of x minus theta when n tends to infinity, Tn of x minus theta less than epsilon. Epsilon is very, very, very small value. Very, very, very small value assume. So the probability that Tn minus theta, the difference between the statistic and the population parameter is less than very, very small value అంటే ఈ రెండు చాలా దగ్గరగా ఉన్నట్టే కదా దాని మీనింగ్. సో ఈ రెండు చాలా దగ్గరగా ఉన్నప్పుడే ఇది చాలా చాలా తక్కువ అవుతుంది. సో దీని ప్రాబబిలిటీ ఎంత ఉండాలంట, 1 ఉండాలి. అంటే ఈ Tn theta చాలా దగ్గరగా ఉండాలి when n tends to infinity. Then we can say that the estimated Tn of x is a consistent estimator. Next, efficiency. So in this efficiency we will compare two estimators, Tn of x1, Tn of x2. Let's consider this is T1 and T2. Simple ga దీన్ని estimator T1 and estimator T2. Now this T1 is a estimator with a variance V1 and this T2 is an estimator with the variance V2. So V1 is the variance of the estimator V1, V2 is the variance of the estimator V2. Now my efficiency is given by V1 by V2. That is the ratio between the two variances. Now if it is greater than 1, greater than 1 unte enti meaning ante V1 is greater than V2. V1 is greater than V2. So in this case we can say that estimator 2 is most preferable than estimator 1. So in this case we can say that estimator 2 is most preferable than estimator 1. So whenever we have more variance, that is less efficient, that is less efficient estimator. Whenever you have less variance, that is more efficient estimator. You have to remember this point. ఎక్కువ వేరియన్స్ ఉంటే అది లెస్ ఎఫిషియంట్, తక్కువ వేరియన్స్ ఉంటే దట్ ఈస్ మోర్ ఎఫిషియంట్. ఇక్కడ అదే రాసాం. ఇక్కడ V1 ఈస్ గ్రేటర్ దెన్ V2 అంటే V1 వేరియన్స్ ఈస్ గ్రేటర్ దెన్ V2 అంటే ఎస్టిమేటర్ 1 ఈస్ లెస్ ప్రిఫర్డ్ దెన్ ఎస్టిమేటర్ 2. అలాగే ఇఫ్ V1 బై V2 ఈజ్ లెస్ దాన్ 1, లెస్ దాన్ అంటే దాని మీనింగ్ ఏంటి? V1 ఈజ్ లెస్ దాన్ V2. అప్పుడు మనం ఏం రాసుకోవచ్చు? estimator T1 is more efficient than estimator T2 because here variance of estimator 1 is less than the variance of estimator 2. ఎప్పుడైతే ఎక్కువ వేరియన్స్ ఉంటో దట్ ఈస్ లెస్ ఎఫిషియంట్, ఎప్పుడైతే తక్కువ వేరియన్స్ ఉంటో దట్ ఈస్ మోర్ ఎఫిషియంట్ estimator. Now sufficiency. Now before going to sufficiency you have to learn a small concept, that is L, which is equal to product of the function by taking all the possible values of the x. Let us consider the probability function. Let us consider probability function Poisson e power minus lambda into lambda power x by x factorial. Now we have considered a sample. In this sample we have x1, x2, so on up to xn values. So substitute each and every sample point in the probability function and multiply all the functions. ఇప్పుడు మనం ఏం చేస్తాం చూడండి. ఇక్కడ e power minus lambda into lambda power x1 divided by x1 factorial into e power minus lambda into lambda power x2 by x2 factorial, so on e power minus lambda into lambda power xn by xn factorial. సో ఇట్లా ప్రోడక్ట్ అంతా రాసినప్పుడు ఈ ఫంక్షన్ని మనం L అని అంటాం, లైక్లీహుడ్ ఫంక్షన్. సో ఇలా L రాసినప్పుడు if we can rearrange all these things in the form of g of theta into t of x into h of x, ఇట్లా టూ ఫంక్షన్స్గా రాసుకున్నట్టయితే మనం ఇలా టూ ఫంక్షన్స్గా రాసుకున్నట్టయితే దిస్ h of x is independent of theta and this g theta of t of x is purely dependent on theta, purely డిపెండెంట్ ఆన్ టీటా. సో ఎప్పుడైతే మనం ఈ ఫంక్షన్ని ఇలా టూ ఫంక్షన్స్గా విచ్ ఈజ్ ప్యూర్లీ ఇట్లా టూ ఫంక్షన్స్గా రాసుకున్నట్టయితే ఒక ఫంక్షన్ ప్యూర్గా డిపెండెంట్ ఆన్ టీటా అండ్ అదర్ ఫంక్షన్ ఇస్ ప్యూర్లీ ఇండిపెండెంట్ ఆఫ్ టీటా. సో ఇట్లా ప్రోడక్ట్ ఆఫ్ టూ ఫంక్షన్స్గా రాసుకున్నట్టయితే దెన్ వీ సే దట్ ద ఎస్టిమేటర్ దిస్ Tn of x, ఇక్కడ ఎస్టిమేటర్ ఉంది చూడండి, Tn of x is a sufficient estimator. So till now what we discussed is in this class the sampling and non-sampling errors, which are sampling errors and which are non-sampling errors. You have to be very specific. So there may be direct questions we can ask in the examinations. ఏదైనా ఒక ఎర్రర్ ఇచ్చి it comes under sampling error, non-sampling error, or ఏదైనా sample which is a sampling error అని ఇచ్చి కింద 4 ఆప్షన్స్ ఇస్తారు. దాంట్లో you have to select a sampling error or non-sampling error. సో అట్లా క్వశ్చన్స్ ఇచ్చే ఛాన్సెస్ ఉన్నాయి దీంట్లో నుంచి. నెక్స్ట్ స్టాటిస్టికల్ ఇన్ఫరెన్స్ అనమాట. స్టాటిస్టికల్ ఇన్ఫరెన్స్లో ద డెఫినేషన్స్ ఆర్ లిటిల్ బిట్ ఇంపార్టెంట్, లైక్ డైరెక్ట్ డెఫినేషన్స్ క్వశ్చన్స్ అడిగే ఛాన్స్ ఉంది. ఎస్టిమేటర్ అండ్ ఎస్టిమేట్స్ అండ్ పారామీటర్ స్పేస్ ఏంటనేది. సో అన్బయాస్నెస్, అన్బయాస్నెస్లో మన రిలేషన్స్ బాగా గుర్తుపెట్టుకోవాల్సి ఉంటుంది. సో sample mean is directly unbiased estimator of population mean, whereas our sampling variance is not an unbiased estimator of population variance, but the expectation of small capital S square which takes the function 1 by n minus 1 into summation x minus x square, that is an unbiased estimator for the population variance. అలాగే consistency చూసుకున్నట్టయితే when our sample points n tends to infinity, then our estimator function will obviously have to tend to our population parameter, as because when n is tending to infinity, that means our sample is tending to the population. So obviously our statistics, our estimated function has to tend to our population parameter. Now efficiency. So in this efficiency, you have to remember the most important thing: whichever the statistics has the more variance, that is less efficient. Whichever the which has the less variance, that is the more efficient estimator. Next, sufficiency. So in the sufficiency, the likelihood function is really important here. When you are taking the probability function and a sample, the product of the function by considering all the sample values is nothing but the likelihood function. So when you can write the likelihood function in terms of two functions, which is purely dependent on the parameter theta, and other function is purely independent on the parameter theta. So when you can write like that, then we can say that the estimated Tn is a sufficient estimator for the parameter. Okay, in the next class we will discuss the testing of hypotheses and the small sample test and the large sample test. Thank you.